what we've got are these three directions. When we have a vector r that's pointing this way, and this is just like I had in the diagram, so r pointing this way, r pointing this way, f pointing up this way, we need to combine those to give us a direction that points out of the board. That's what we want. That's what we want this cross product to do, so that we can maintain this relationship tau vector equals I alpha vector. Now, how are we going to do that? Well, as I said, we're going to use a different version of the right-hand rule. When I was in college and I was first learning this, we had only one form of the right-hand rule. What I've got, or what I've learned since then, I should say, is two more. So I can actually teach you three different ways of applying the right-hand rule. They give you exactly the same result. They have to. But depending on whichever you like best, you can use whichever one you want. Or use them at different times, depending on the situation, however it would be easiest for you. Let me show you kind of a similar way of using the right-hand rule that we did before when we were looking at motions. And that's actually the first one that I learned. So it involves curling your fingers. What we do is r cross f. We point our fingers in the direction of the first vector, which is r. So point your fingers in the direction of r. And then rotate them into the direction of the second vector. So I'm going to point my fingers in r and rotate them up to the direction of f. Now, if I put my hand this way, I couldn't do that. I'd have to bend my fingers backwards. So in order to rotate my fingers upwards, I've got to have them in this orientation, to roll them upward toward f. My thumb then points in the direction of the cross product, which we can see is out of the board. So point your fingers in the direction of the first vector, rotate them into the direction of the second vector. Your thumb will then point in the direction of the cross product. Now, this brings about a very interesting result that you might think about immediately. What if we were to take f cross r? Well, in that case, if I point my fingers in the direction of f and rotate them into r, actually I've got to hold it this way. So f to r. So this actually gives us a vector into the board. So here, r cross f with this orientation of r and f gives us a vector out of the board, while f cross r with this orientation of f and r gives us a vector into the board. So it turns out that r cross f is equal to the negative of f cross r. So that's an unusual characteristic of the cross product. It is not commutative. If you remember when we looked at the dot product, it didn't matter if we took a dot b or b dot a. We got the same result, a scalar in this case. But here, if we take r cross f, we get a vector in the opposite direction. Same magnitude. We end up with the same magnitude because r f sine phi is the same as f r sine phi. The angle between the vectors will be the same. If f and r are this way or f and r are this way, it doesn't matter. The angle between them is the same. But when we take the cross product, we end up with the negative direction. Okay, very interesting. Something to keep in mind. All right, what are the other two forms of the right-hand rule? The other form that seems to work well for many people is point your fingers in the direction of the first vector. So this would be r cross f, it would be in the direction of r. So I'm going to point my fingers in the direction of the first vector. Then point your thumb in the direction of the second vector. Fingers and thumb. Oh, no, wait a second. You point your thumb in the direction of the first vector. So here's r. Point my thumb in the direction of the first vector. Then you point your fingers in the direction of the second vector. So I'm going to point my fingers in the direction of the second vector. Okay, so here's r, here's f. Your hand then pushes in the direction of the cross product r cross f. And you see my hand pushes out of the board. So thumb in the direction of the first vector, second vector, hand pushes in the direction of the cross product. So one more time, r, f, this way. You have to do a little twisting sometimes. R, f, your hand points out of the board. in the direction of the cross product. Okay? Very good. So that's the second method. Let's just look, what if we had F cross R? F cross R, thumb in the direction of F, fingers in the direction of R, cross product would be into the board. Your hand pushes into the board, so we see it's the opposite direction. Oh, let me just mention why you have to use the right hand rule, because if you use the left, and I point my thumb in the direction of R, and my fingers in the direction of F, I get exactly the reverse of what happens with the right hand. So you can see your hands are mirror images of each other, and if you line them up, they push in opposite directions. So, gotta make sure to use the right hand rule. Or, I mean, if you really wanted to point your left hand, your thumb in the direction of the second vector, and your fingers in the direction of first, you could always do that with the left hand if you wanted. All right, third version. Again, with the right hand, make a set of mutually orthogonal axes with your thumb, index, and middle finger. Looks like this. Notice my index and middle finger are perpendicular. My thumb is perpendicular to my index finger. My thumb is perpendicular to my middle finger. So they're all mutually orthogonal. In other words, they're all at a right angle. Now, just remember, 1, 2, 3. 1, 2, 3. Point your index finger in the direction of the first vector, which would be R. Point my index in the direction of R. Point my second in the direction of F, this way, so R, F. My thumb then points in the direction of the cross product, which again is out of the board. So first vector, second vector, thumb, the cross product. So again, the cross product is out of the board. And again, notice if we had F cross R, F, R, my thumb points into the board. So if you reverse the order of the vectors, you reverse the order of the cross product. Now, just one little warning. Make sure that when you make your mutually set of orthogonal fingers, it's like this and not like this, okay? Don't do that. You don't want that. You want this way, like this, okay? So, just make sure that you use the correct form of the cross product. Okay, well, we are going to take a look at some more of the properties of the cross product in the next lecture and see how we can apply all of these things that we've been looking at to some problems. I'll see you then.